In this example problem, I want to show you how to break each of these vectors up into their x and y components and how to write your final answer in unit vector notation. So I'm going to go through this kind of quick because I've kind of went slow through the previous example problem, so I'm hoping you're starting to pick up on this. So I'm not going to walk through each one. I'm just going to walk through one example problem, and then I'm going to ask you to do the other three. So let's look at vector A. Now it doesn't matter that this doesn't start at the origin. Remember, a vector is simply, or a vector is defined as having a magnitude, which we have here, and a direction, which we have. So it does not matter that this is not placed at the origin. So the first thing that I do is I set up my right triangle, okay, draw my other side there, and we know that that makes a nice right triangle down on the corner. So I'll draw my box to make sure that you know where your right triangle is. So we know that this is a right triangle, so first thing I do is I write down SOHCAHTOA, okay, just to help me remember what my trig functions are equal to. So SOHCAHTOA. Alright, so I'm going to start with sine. So sine of the angle theta, which in this case is just going to be 40. Okay, I use the angle that's given, sine of 40 degrees, is equal to the opposite side. So here's my angle. I go to the opposite side. So keep in mind that this side of my triangle is vertical like my y-axis. So that is my y component of A. And likewise, the other side of this triangle is horizontal like my x-axis. So that is my x component of A. Okay, so AX and AY. So for this case, sine of 40 is the opposite side, which in this case is AY. Okay, so I write AY divided by the hypotenuse, which in this case is 1.5 meters. So divided by 1.5 meters. Okay, actually just leave off the units just to make it look a little cleaner. So now to solve for my y component, I multiply both sides by 1.5. Multiply this side by 1.5. And what I get is my 1.5's cancel on the right hand side, and I get 1.5 sine of 40 degrees is equal to a y, which rounding to 2 sig figs, since my angle is 2 sig figs and my magnitude is 2 sig figs, I round my y component to 2 sig figs, so that's 0.96. Okay, then I throw my units back in this case it's meters, is equal to a y. Now I check my sign. You can see that this is pointing toward the first quadrant. Okay, so it's sort of up and to the right. So that would be the first quadrant. So I know that my AX needs to be positive and my AY needs to be positive. So this is good that we have a positive number. Now I suggest that you pause the video and you try to solve for the X component on your own, and then restart the video to check your answer. Alright, so to solve for the x component, I do the same thing, except this time I'm going to use a different trig function. This time I'm just going to go to cosine. Again, if you're not sure which trig function to use, just go to the next one and see if you can solve for anything. So I'll start with cosine this time. So I've got cosine, okay, of the same angle, 40 degrees, is equal to, okay, in this case, it's going to be the adjacent, so it's going to be AX divided by the hypotenuse, which is still 1.5. Again, just leaving off my meters to make it look a little cleaner. And now I do the same thing. Multiply both sides by 1.5. Multiply this side by 1.5. Okay, on the right-hand side, my 1.5's cancel out. And I'm left with 1.5 times cosine of 40 degrees is equal to AX. Okay, typing this into my calculator, I get, so rounding to 2 sig figs, I get 1.1 meters is equal to AX. Okay, so now that I have my y component and my x component, I can write vector A in unit vector notation. So I've already copied these on the next page. So I've got my x component of 1.1 and my y component of 0.96. So I can say in vector notation, and I've already rounded to the proper number of sig figs, so this will be my final answer, is A. Okay, so vector A is equal to 1.1 meters. I like to put these in parentheses just to make it a little clearer. Then I do my x hat. Okay, so I throw my unit vector x into the problem, plus 0.96 meters. I throw my unit vector in there, y, and that's my final answer. So this is how you express a vector A in unit vector notation. Alright, I hope you enjoyed this video. If you have any questions, just raise your hand and ask.